This video is part 5 of the video series describing the Automated Rose Ornamental Lathe. In this video I'll be describing and demonstrating the software that produced these ornamental lathe designs. Hello, I'm John Manier. This will be part 5 of a 5-part video series on the design, construction, and testing of a fully automated or CNC rose ornamental lathe. In this video I'll be describing the software that I developed for the control and operation of the system. I used the Arduino software along with the Nextion display software to design the software to operate this system. The software is a work in progress, and I'm sure there will be many changes, new features, and new programs in the near future. I currently only have a single RAM rotary tool for cutting operations, but I do plan on producing a fly cutter in the near future, and I'm sure the software will change at that time. In this video I'll be briefly describing the various programs that I've written to date. I will show some of the actual cutting operations and some of the results of using these programs. The actual cutting operations can often be quite slow. Therefore, I will be editing these videos and speeding them up to reduce your viewing time. This Nextion display panel is the heart of the system. And I've written the system with one main program, which is this program here, which is your main interface program. And from this program you access all the other sub-programs. So I have two main programs on here that run the system manually, which I described previously. The first one is the spindle control, and the second one is the XZ control. And these programs down below here are all the individual programs for doing specific patterns by the system. So let me first go into the spindle manual control. From here you can access the spindle to do different things manually. I can have it run clockwise, counterclockwise, and in various modes. And the first thing to set up is the speed. So right now it's set for 1 revolution per minute. So I can change it just by deleting that and maybe putting in 5 revolutions per minute. That'll run it much faster. And then I can jog it forward or backward just by pressing the button here. See, that runs it forward or backward. Or clockwise, same thing. And let me move this thing so it doesn't rock. The other thing I can have it run continuously. Again, either forward, stop it, have it run backwards. And this is used when you want to run something manually. You want to have the system run continuously, and you want to manually have it make some cutting patterns. So it's like a manual operation. And if you ever want to do indexing on something, this is where this comes in handy. You set the number of degrees you want it to rotate. For instance, if I want it to run, say 45 degrees, type 45 degrees in there, say clockwise, it'll turn a quarter of a turn and then stop. Have it run reverse, the same thing. So this is used when you want to have a program run that you want to do something, make some patterns on your piece, rotate it a certain number of degrees and repeat it. As I mentioned earlier, I'm going to be making some changes to this program. And the one change I want to make is I want to change this degree to enable you to do parts of a degree. So maybe you want to do, 15.15 degrees. So I'm going to change this to not just have whole degrees, but have up to 1/100th of a degree. So that number will be changed in the near future. As I mentioned, I will be making a lot of changes to the software. And as I use the system and develop new ideas and new programs, I'll be changing some of the parameters. And then to get back to the index page, I can just go here and go back to the index page. And I did something very similar for the XZ movement. You can just press that button here. And now there's two parts to this screen. This part on the right is just where you can tell it to go up, down, left or right. But before you do that, you set your speed. Right now it's set for 5 inches per minute. And to change that, I can just delete that and maybe have it run twice that speed, 10 inches per minute. Do the same thing on the x-axis. Have that run 10 inches per minute. So this goes anywhere from 1 to, you probably don't want to go over 20 inches per minute. That gets too fast. But so if you say from 1 to 10 is normally what you do with the system. Then this system on the right here is where you tell it to go. Either right or left or up or down. And I normally use this to set my 0 position when I'm first starting the program. And that's what this portion on the right here, or the left here, is for. I can position my piece. Say I want my tool to go right against my board. I just move it in until it touches the board. Center it. And once it's all set up, then I just set my home position for both the X and Z. So you notice right now, this is the actual position. Both the X and the Z actual positions. You see they're negative numbers now because I moved everything to the left and down. So I can just press the set button, and that changes those numbers to 0. And now that's your home position. That if you're doing anything else in the future, you want to go back to home, you just say go to home, and it goes back to home. For example, let me move it away, both directions, and you see the numbers have changed here. Now if I say go to home, it goes to home, changes it to 0, do the same thing in the X direction, and it's back to home. So this program is used a lot in other programs where I want to set my home position. I usually want to set my tool in a certain position right against my board as a starting point, and then I'll set my home position there, and then go back to the other program to start the operation. But this homing position is quite useful. And then the rest of this are the various programs I've written. So I've written a total of 17 programs, including the programs I've written for the manual control for the system. And I will be writing more in the future. And some of these programs will be changed in the future, and let me describe those kind of briefly. So right now this screen is set up that these programs on the left print or cut on the face of an item, and these programs on the right cut on the side of an item. And this may change in the future. In fact, as I add more programs, I'm probably going to have to split this screen up into two screens. One for face operations and one for side operations. So but right now it's all on one screen, but I see this in the future will be two separate screens. Well, the first program I wrote was for printing patterns on the face of index cards. And that's this program right here. Now this is a system that's set up. I can input up to 6 different patterns to run continuously, one after another. And I just set the distance from center. So for example, on this first one, if I want to make this say 1.5 inches from center, I just press in 1500. And that takes 1.5 inches from the center. If I want the second one to be maybe 1 1/4 inches from the center, type that. And I put in 5 or 4 others, so there's a total of 6 patterns I can print. Next I set my speed. Maybe I want to run a little bit faster than that so it doesn't take so long. Let's make it 4 revolutions per minute. And then to start that I just press start. But let me describe how I set this system up first. I mentioned earlier I made some disc, and this was a 3D printed disc. It has a 3/4 inch hole, which is with a set screw in it, and I embedded some magnets in the surface, and my chunks are just held on here with some set screws so that can be removed, and this can be inserted in its place. And then I can place an index card on here and just hold it in place with some additional magnets. So my primer is all set up now, but I have to initialize my system. And to start that, I have to go to my index page and go to my XY control and then move the pen in so it just touches the paper. Usually what I have to do here is lower the speed and make that 2 inches per minute. Okay, and then once that's set, then I have to set my home position. That sets my 0 position. So everything is set to 0 now. Now I go back to my index page, go back to my print pattern face. Now there's 2 programs here. I have a start run and initialize. What the initialize does, it moves it away from the paper about 1/2 inch, and it moves, then when you start to run, it moves the pen in position and moves it in and starts your actual printing. So let me initialize it first. Okay, that moved away from the paper. Now we're all set to start our run. Now I can repeat the pattern by just changing the parameters at different angles, Or in this case, what I'm going to do is I'm actually going to change the phasing. So let me change the phase by 2 steps and just rerun it. And that completes it. And here's a completed pattern for the one I just finished. And here's another one I did previously, which is a little bit nicer. This next probe I actually showed in a previous video, but it's the system for truing up the face and side of a cylinder. This is quite important because quite often when you bring a piece from another lathe and you put it in a chuck on a system, it may not be perfectly centered. It may be off a slight bit. Or maybe it needs trued up, or maybe you erase some material off the surface. In this case I have a previous board I used. I'm going to erase the surface off that piece. But this brings everything true, so when you go in to put a pattern on it, it'll be perfectly aligned. So I've been using this quite a bit when I'm doing my pieces. So there's 2 programs here. One is for trimming the outside surface of the cylinder, in other words this surface here. And the other is for truing up the face, the flat surface on this surface. So there's 2 separate programs on here for 2 operations. And I have created a new dust collector for this system. These are all 3D printed on my 3D printer. And I'm also trying something new. Previously I had used this 1/4 inch cutter. Actually a cutter for carving. But I've actually found a 1/8 inch end mill. I couldn't find a 1/4 inch end mill with a 1/8 inch shaft. So I'm going to try this 1/8 inch end mill for the first time. It may do a better job in getting a surface, but it means I got to run a little bit slower. So we'll see how this works. So let me speed up this revolution on the outside cylinder. Let me see if I can make it 15 revolutions per minute. And my x-axis or my z-axis revolution or rotation is 0.01 inches per minute. So it's moving real slowly in this direction and turning quickly. So it should give you a nice smooth surface. I sped this section of the program up 20 times the actual cutting speed to reduce your viewing time. Each time I went down about 1/10,000 of an inch until the surface was perfectly clean. Okay, now we have a surface that's perfectly smooth and clean and perfectly symmetrical, so if I make patterns on the outside, I'll get perfect patterns. And the front facing works the same way. I showed that in the previous video, but the same thing. You put in your speeds and your depth of cut, and just keep repeating it until you get a nice clean surface. This next program demonstrates the cutting of rosette patterns on the face of a board. So this is my main screen now, and I can cut up to 5 different patterns on this board. Each one of these, I determine how far from the center I want to go out, and this is the radius. So my board is about 2.5 inches in diameter, so I can go out 1.25 inches on each side. So probably the max I want to do is 1.25 inches. So let's do 1 inch. So I can just type in, delete that, 1. So that's 1 inch. 1,000 is one. Oh, need one more 0. So that's 1 inch. So that'll give me a pattern 1 inch. And this number over here indicates which side of center I want to cut on. 1 is cutting on the front side, or the side towards the console here. And if I put a number 2 in, that cuts on the opposite side. It gives you a slightly different pattern. So let's do that. Let's do the second pattern. Let's change that to a 2. So it's going to cut on the opposite side, so we can see what the difference in pattern is going to look like. But let's make it a little bit space. So let's maybe make this, say 800 thousandths of an inch. So it's almost 1/4 inch separation between the two cuts. I'm cutting to a total depth of 50 thousandths, and I'll be cutting in steps of 10 thousandths of an inch. And I can change these. I can make this depth either shallower or thicker, and I can go make my total depth to go even deeper. In fact, let's do that. Let's go maybe down to let's go down to maybe 70 thousandths. Make it even deeper, and do the same thing for this one. Make it 70,000 inches deeper. So it's going to cut two patterns, one on the front side, an inch radius, the second 0.8 inches on the opposite side of the center portion of the board. Both will go down 70,000 of an inch, and they'll go down in 10,000 inch increments. So there'll be 7 different steps that'll go in to cut the board. This over here will show my axle position of the blade as I'm cutting, and these pattern numbers over here will turn red as I'm cutting that layer, so you know which one I'm actually cutting. So first of all, I initialize. What initialize does, it moves the blade away from the board a ½ inch, just to give you some clearance. So let me do that. So that moved the blade away from the board a ½ inch. And then when I press run, it'll come in, touch the board, and start doing the process, going through sequentially 1, 2 to create the patterns. So when I'm ready to turn it on, I got to turn my blade on first, and then I'll start the run position. So I'm using a pointed blade, and it's running at 12,000 RPM. So I just press start, and everything else is automatic. I go through the whole process, 7 times 2 would be 14 steps continuously with no interruption. So now it's moving out an inch, moving into the board. And another thing I forgot to mention, this over here is 1. That indicates that the spindle motor is rotating at 1 revolution per minute. So it's fairly slow. And I can speed it up. I can make it up to a max of 10 inches or 10 revolutions per minute. But usually I'm using 1 or 2 revolutions per minute. That's a good speed. So this just runs automatically. So you just turn red, indicating it's cutting pattern 1. And the depth right now is 0. It's actually cutting 1 time on the actual surface of the board. Just making a score mark on the surface. And it actually rotates, not 1 full revolution, it rotates 370 degrees. I want it to go past center a little bit. So instead of just doing 360 degrees, I actually have it cutting 370 degrees. So each step will do 370 degrees of revolution before it makes it in cut in. Now it just went in 1/10 of an inch, or 1/10,000 of an inch, to make the first pattern cut. And that'll do 7 more until it gets to the full 70,000 inch depth. Here I just increased the speed of operation to 20 times the actual speed, just to reduce your viewing time. Now the one thing, this board I'm using is multi-layered laminates. I created a bunch of laminates with my Accu-Slice system, probably about 25,000 inch thick, glued them together. And as I'm cutting through, you see the additional colors coming through, the red and the brown coming through. And you can see when this pen starts cutting the second pattern, it moved to the opposite side, in other words, the far side of the board. And the resulting pattern is actually like a phased change. So it's almost like the opposite of the previous cut. And I finished the cut, and of course it turned off both patterns. And here are some examples of rosette patterns cut on the faces of some boards for this initial testing of the software for the Automated Rose Ornamental Lathe. Okay, this next program is for creating rosette patterns on the side of cylinders. That's this program here. For this project, what I plan to accomplish is to create a basket weave type pattern. I'm using the same 1/4 inch bit that I used previously. I'll be cutting a group of 3 patterns around the cylinder, each of them spaced 0.6 inches apart. Later I'll come back and create a second group spaced between each of these previous patterns. In other words, at 600 thousandths and 1.1 inches. But I'll change the phase for these cuts to enable the creation of the basket weave type pattern. I'm speeding up this video 10 times the actual cutting speed, and I edited it quite a bit to reduce the viewing time. And this is cutting the second layer. And you see the spacing between the layers. And I'm cutting the final third layer. And I create the program, change the phase, and cutting in between the previous patterns. And you see it's offset by like half of a segment. And there's just 2 layers I'm cutting here. That's the first layer. And then I'm cutting the second layer. Well, this was a segment of block I had laying on the shelf and had it cracked. So it was just a piece of scrap I wanted to try out. This is my first attempt using the system. And of course I staggered the layers by half a phase. And that's the resulting pattern. Came out pretty nice. Except for the crack. This next program describes the cutting of index patterns on a face. From this main screen, you can once again enter multiple patterns. You first indicate the distance from the center of the board, and then you enter the number of segments per 360 degrees of rotation. The program automatically calculates the angles. The offset angle is used when you want to stagger a second or third pattern relative to the previous pattern. You then need to indicate the depth of your cuts and the speed of cutting. Here I'm showing the cutting of the second pattern layer of indexed holes. For this layer I set the offset angle to stagger the holes between the holes in the previous layer. I also created a program to create index patterns on the side of a cylinder, but as yet I have not tested this program out. Here are a few index patterns on the face of a disc. In most cases I created some rosette patterns on the face and then added the index points for some additional details to the design. This program cuts threads or spiral patterns on the sides of the cylinder. For this program you enter the starting position, the final position, the spindle speed, and the z-axis speed. The system will calculate the resulting threads per inch. You also have the option of creating left-hand or right-hand threads. Here I'm using the pointed cutting tool and taking multiple passes on the depth of the cut till I achieve the required depth. And here's the finished piece after a light sanding on a floppy disk sander. This program is very similar to the previous program, except that you're cutting the patterns on the face of the cylinder. Once again, you enter the starting position, the final position, and the various speeds. And here's the finished pattern after light sanding. Here's another idea for a project. For this design I installed a sine wave rosette onto the Rose machine and activated the rocking motion. I then used the spiral face turning program to produce this unique design. And here's the resulting pattern that was created. The final 2 programs are the double helix pattern and the crosshatch pattern. The double helix pattern was my first attempt to create a crosshatch pattern, but I was not able to get the results I had anticipated, so this program will probably be eliminated in the future. I spent 3 full days creating the crosshatch pattern program. It was a challenge designing the software to enable the accurate cutting with all the various parameters available and then getting everything properly aligned, especially with me cutting over top the previous cuts. But after a good deal of recalculations and persistence, I was able to get some perfect results with this crosshatch pattern program. I demonstrated this program in part 1 of this video series, in which I described the truing up of the outside surface and then generating the double helix pattern. Here's a short demonstration of the cutting of this double helix pattern. I demonstrated this first cutting of the double helix pattern in video 1 of this series. Here I'm demonstrating the recutting of the pattern cutting the pattern deeper to achieve a more pronounced pattern. As can be seen in this recutting of the pattern, the alignment of the cutting is precise, with no deviation from the first cutting pattern. Here is the finished pattern after a light sanding to remove the fuzzies from the surface. This concludes this 5-part video series on the software design, development, and testing of the Automated Rose Ornamental Lathe. These are some of the software designs that were demonstrated in this video. The development of this Automated Rose machine is still a work in progress, and there will be many design and software changes in the future. During the development of this final program on the double helix pattern, I learned and developed a few new ideas, which I now need to incorporate into many of the previous programs. I currently have only used the RAM rotary tool to generate the program described in this video. I'll be adding a spindle motor and also a fly cutter in the near future, so I'll be further modifying these programs and adding additional programs as a need arises. Once again, thank you for watching this video. If you have any questions, concerns, or comments, leave them in the description below or send me an email, and thank you for watching.